80.
80% of the scores that we got. You take probably in a higher range of those, right? Or higher scores for those?
No, I just take all your scores.
You just take those.
Everything.
Okay.
Yeah, so as a quick reminder, only count 80% of your quiz points. So, and plus I give you a point every day for your name. So that's called grade inflation, right? So if I give you any bad questions, I give you your net point for your name. So I'm cutting you already some slack, right? Okay. All right. So today is one of my funner lectures, I think. You may disagree, but yeah. So we're going to talk about variation. Okay. So let's pretend for a moment. Oh, I'm not sharing my screen. Hopefully I am. All right, let's pretend for a moment that you want to buy 2 potatoes. You buy 2 potatoes from Idaho, and you buy 2 potatoes from Las Vegas. Okay? So 1 potato from Idaho weighs 4 ounces, 1 weighs 6 ounces. You go to Las Vegas, 1 weighs 1 ounce, 1 weighs 9 ounces. Okay? And I'll bet if I pick on somebody, Mackenzie. Mackenzie, can you tell me the mean for Idaho? The mean potato size? 5 ounces. And the mean potato size in Las Vegas?
4.5.
No, it's also 5.
Does it 1 and 9?
1 and 9?
Oh, yeah.
10 divided by 2 is 5. All right. Okay, so there's no difference in the potatoes in Idaho and Las Vegas, right? Who wants to buy the Idaho potatoes? Okay, who wants to buy the Las Vegas potatoes? You're the gambler, right? He wants to strike it big. Okay. All right. So, do you agree that there's no difference among these potatoes, or do you who says there's a difference? Okay. Why is there a difference?
Well, the mean doesn't actually give us this distinct separation in the difference, but there is a difference.
Yeah, the mean's the same, but the potatoes are quite different, aren't they? Okay. Now, one measure. Say it again.
Being the same amount of potato, though.
You are getting the same total amount of potato. Okay. But you want the big potato, and you're going to give him the small potato, right?
Yeah, that's true.
Okay. All right. So one measure of variation would be to just simply say the range. Okay. The range, we could say in Idaho, is from 4 to 6 ounces, or a range of 2 ounces. The range in Las Vegas could be 1 to 9 ounces, or a range of 8 ounces. Okay. So you could say the range is 4 times bigger in Las Vegas than it is in Idaho. Okay. Now, one of the things we could do, let's pretend that we're going to add a 3rd potato in here. And in Idaho, I had a 5-ounce potato. In Las Vegas, I had a 5-ounce potato. Neither my mean nor my range changed at all, did they? So my range isn't really very, it's not very sensitive to small changes like that, right? And besides the fact, this is a Math 2040 class, we got to be doing more difficult calculations than that, right? No? You guys disagree?
No.
Okay, well, UVU disagrees with you. Okay? All right, so I'm going to show you a couple of formulas here, okay, for the standard deviation. Now, let me give you kind of a definition of the standard deviation. Well, 3.2 deals with measures of variation, and we dealt with range already. But standard deviation, the definition I like to give people is and I'm going to use the A word, I apologize, the average, because that's what most people think of, distance from the mean. Okay, I'm going to give you 2 formulas. Okay, they're going to be very similar formulas. One of them is sigma equals the sum of xi minus mu squared divided by capital N square rooted. Okay? This is the formula for what we call the population standard deviation. Okay? The other formula I'm going to give you is very similar. It's going to be S equals the sum of xi minus x bar squared divided by n minus 1 square rooted. That's for the sample standard deviation. Okay? So you're going to notice that those formulas are very similar. Question, what was the first one? The first one's for the population standard deviation. Okay? So how do you decide which formula you're supposed to use? It's a parameter or a statistic because I'm dealing with a population or a sample. Okay, so remember chapter 1 when we talked about populations and samples? We're using that now. We're applying that knowledge now. Which, if you're using a population, you're going to use the first one. If you're using a sample, you're going to use the second one. You guys having trouble seeing it? So the first one is sigma equals the square root of capital sigma times x of I. X of I represents each piece of data you have, minus mu. Now, I probably haven't showed you the mu. That's your population mean. And x bar is going to be your sample mean. Okay, the formulas are identical. You guys know how to figure out a mean. You've always, up to yesterday, you always called it the average. Okay, it's the same formula either way. Add about, divide by the total number you got. So data minus the mean divided by either n or n minus 1. And then we take the square root. So some of you guys like steps. So here's what I'm going to say. These are steps to follow. Now next week, we're going to have a test. I'm leaning towards Wednesday and Thursday. We got no school on Monday. Did you know that?
Yeah.
Sleeping day. That's going to be nice. Okay? So Tuesday, I usually don't do a review, but I think I'm going to do a review this time. So we'll do a review on Tuesday. Wednesday, we'll do the written test. Thursday, we'll do the computer test. Both in here. Okay? You're going to run out of time. I'm just going to warn you. You're going to run out of time if you haven't been practicing on the computer stuff. Okay? Every test. So make sure you practice. Okay? Got to do it quick. Okay? Some of you are going to be like, oh, I had to do all the time. But some of you who don't know Excel as well, you're gonna take the whole hour and wish you had two, probably. I'm just warning you. All right. So number one, the first thing you need to do when you're finding the standard deviation is you need to find the mean. Whether it's population or sample, it doesn't matter. Just find the mean. Number two, okay, as we look at our order of operations, you're going to find the data minus the mean. Okay? Step number 3, what does that 2 mean?
Square.
We're going to square the difference. Number 4, what does this sigma mean? Find the sum. Step number 5, the only difference between these two is you're going to divide by either n or n minus 1. Now, how do you decide whether you're dividing by n or n minus 1? Am I dealing with a population or a sample? And oh, by the way, I'm going to put a star by that step. That step has a special name. It's called the variance. Okay? Later on in the semester, when we get to about chapter 11, 12, something like that. Later on, at the end of the semester, we're going to do a test called the analysis of variance. Okay? Sometimes we like to deal with the variance. Most of the time, we like to deal with the standard deviation. The standard deviation, the last step is take the square root.
What's
Okay.
step 5? Say again,
Divide by n or, sorry, that doesn't look like an or. N or n minus 1. Okay?
On
Question.
number 2, it says data minus mean, so the xi is the data.
Yeah, we're going to go through an example right now,
Oh,
so you can understand it. We're going to follow these 6 steps. Okay? So here's the deal. Yeah, I'm probably going to give you a formula sheet for the test next week. So you don't have to memorize any formulas. However, so I will give you both of these formulas. You're going to have these on the test. You don't have to memorize those, but you should be familiar with them. I am not going to give you these steps. Okay, if you want to memorize those steps, you're welcome to. I'm going to give you these formulas. From these formulas, you should be able to know those steps. Okay, so we're going to find the standard deviation right now, and we'll go through these 6 steps. Bree.
So after you find the sum, you don't multiply it. You don't multiply it.
Nope.
On the numerator.
No, this is not a multiply. This is just add them up.
Oh, okay.
Okay. So let's go through these steps here, and maybe I should set the sum of the difference. No, sorry. Find the data minus e. Square the differences. Find the sum of squares. That's what I wanted to do. Okay. All right. So let's go through an example. Let's pretend that we're back on the farm. Okay. We're going to find 5 potatoes, 1, 2, 3, 4, 5. We want to keep this simple. Okay. Now, step number 1 says find the mean, and I will bet that if I pick on Bree, you can tell me what you think the mean is without thinking too hard. 7.5. There's only 5. It's got to be smaller than 5, right?
Oh, those aren't the numbers. Okay.
Yeah, 1, 2, 3, 4, 5.
Yeah.
What's the mean? 3. Very good. It's also the median. Okay. So, or you can use your average command to find that. On the test, I'm going to give you more than 5 data points. You're going to get a bunch. Okay. All right. So step number 1 was to find the mean. Step number 2 is to find the data minus the mean. Okay. So what I want to do over here is I'm going to make a column that says data minus the mean. Now, by the way, if you make it easy for me to figure out what you're doing on your spreadsheet, I'm more likely to give you points than if I don't have any clue what you're doing. I'll just be like, I don't know what they're doing. Okay? So please label things, and it will help you get more points. Okay? So what I'm going to do is I'm going to take the first data point, the 1 ounce potato. I'm going to subtract off the mean. Okay? We're trying to find the average distance of the mean. Before I do that, let me ask you. No, we'll finish that. The data minus the mean. Now my question is, do I need to F for any of these numbers? John?
No, you don't.
No, you don't? Is there a difference of opinion? Who says no? 1? Who says yes? 1? There's more than 2 people in this class. Okay, Dari, what do you say? You say yes, right?
Yeah. Because if you don't F for the mean, stations, it's going to shift.
So are you saying I want to F for the mean? Is that what you said?
Yeah.
Do. Because we always want to subtract the 3, right? We don't want to subtract a blank cell, right? So 1 minus 3 is -2, right? So yes, Dari was right. You're all going to have to study with her. Okay? All right. So now let me look at this. Let's just pretend for a moment. Okay. I don't want you to do any fancy calculations. Just kind of a guess in your head. I'm going to pick on Erica. If you were to look at those 5 numbers there and ignore the negatives for a moment, okay, what would you think the average would be? Two? Well, it's got to be less than 2, right?
0.
It's got to be more than 0. 0 would say there's no difference in the numbers, right? Probably be in between. How about in between 1 and 2, right? Okay. So we're going to do a guess. We're going to guess that about, let's say 1.5. Okay? Does that make sense? When you look at those numbers, if you ignore the negatives, the mean looks like it's about 1.5. Okay, does that make sense? Yes?
Just run through really quick, we had an F4 again, and it's not working for me right now.
Okay, so if you click on equals, you click on the 1, you subtract the 3, and then you press F4, you should get dollar signs in there.
Then you got F4 cell. Thank you.
Does that help? All right. Okay, so we did a guess of about 1.5. We think there's about a difference of 1.5. Okay? All right, so now we've done step 2, data minus the mean. Let's do step number 3. Step number 3 says square the differences. Okay? So I'm going to say square it. Okay? So I'm going to take this number 2, this negative 2, and I'm going to raise it to shift 6. That puts a little caret thing. Negative 2 to the second power. Now, do I need to F4 any of these?
Yes.
Yes? No?
No.
No.
That was a trick question.
Well, apparently was a trick question. It wasn't intended to be. Okay? All right, so I don't F4 any of these because I want this formula to change every time I copy it. Okay? Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Right? Does that make sense? Okay? We're trying to use nice, easy numbers here for the first time you've done this. Okay? All right, so step number 4 says find the sum of the squares. Find the sum of the squares. Okay? Now, I'm going to use my auto sum button. Okay? So if we add all those up, we get a sum of 10. Okay? Step number 5 says divide by n or n minus 1. Which one am I going to be doing? Okay? If these are potatoes, do you think this is a population or a sample? Probably a sample. There's probably more than 5 potatoes in the world, wouldn't you say? Okay? But here's what I'm going to do. Okay, I just want to see what the difference is. So I'm going to do the population variance, and I'm going to do the sample variance. More than likely, sample is the correct way to do this one. We're talking about potatoes. So I'm going to take this, and I'm going to divide by 5 minus 1 is 4. My sample variance is going to be 2.5. If I assume this is a population, 10 divided by 5 is 2. Okay?
I'm sorry.
Do
What you did for.
Oh, you divide by the mean?
no. I'm dividing by n. What's n? N is my sample size. How many potatoes do I have? I've got 5 potatoes. Okay? So if I assume that this is a population, these are all the 5 potatoes in the world, or maybe I've got a super small farm, a garden, only got 5 potatoes because potato bugs got everything else or something. Okay? I'm going to take the sum, I'm going to divide by 5. 10 divided by 5 is 2. 10 divided by 5 minus 1 is 4, is 2.5. Okay? So you can see there's a slight difference on whether I determine if I'm working with a population or a sample. In this case, sample is probably the correct answer. I'm just doing this both ways just so you can see what the differences are. Okay? The last step is to find the population standard deviation and the sample standard deviation. Okay? In either case, I'm going to take the square root of the square root of 2. Now remember, our guess was 1.5. Square root of 2 is 1.41. So 1.5 was a pretty good guess, right? And if I do the square root of the sample variance, I'm going to get 1.58. Okay? Now, in real life, if my n's are large, if I'm dividing a big sum by 1,000 or by 999, these numbers aren't going to be very different, right? But if I'm only dividing by 5 or 4, they're going to be a a more significant difference, okay? But in either case, about 1.5.
Show us how to do the square root again.
SQRT equals SQRT, parenthesis, and then you just click on whichever cell that you need. Okay? All right, so I want you to know.
Punch into the sample variation.
Can't hear you.
What formula did you punch into the sample variation? Let's see what you found.
Sample variation is the sum that I found here, divided by 4, because I've got 5 data pieces. 5 minus 1 is 4.
Oh, you just punched in.
Yeah, I just punched in a 4. Okay? All right, does that make sense? So I want you to know that back when I was in college, 100 years ago, we didn't have computers. And I had to do this all by hand. I'm letting you use the computer. Now, let me ask you another question. Do you think Bill Gates has a nice, easy way to find the standard deviation? He does. Can you use it on my test? Only if you want 0 points. Okay? The steps I went through, you need to know how to do this. But I will tell you this. If you want to check your answer, I'll let you check it for free. You can walk out of the test knowing whether you got this question right. Okay? Equals STDEV. And now they've got a dot P and a dot S. What do you think the dot P and the dot S stand for? Population and sample. Okay? So if I want to find the population standard deviation, I'm going to just highlight my data and press enter, and hopefully the answer is 1.41. And if I want to find the sample standard deviation, I'd use the dot S, and there you go, 1.58. You are now as smart as a computer. Okay? Pretty cool? All right, now you may be asking yourselves, why do I care? Right? Who's asking that question? Only one person, too? You're all a bunch of liars. Except for two honest people in here. Okay, so here's why this is important to know. Okay? I've probably told you that our most favorite distribution in all of statistics is what's known as the normal distribution. Okay? The 2 most important numbers of the normal distribution are what's known as mu, the Greek letter mu. It looks like a U with a tail on the front, okay? And sigma, okay? This is the mean, this is the standard deviation. And I'm assuming I'm using a population in this case, okay? So the mean is given by the Greek letter mu, and the standard deviation, this would be 1 standard deviation, this is -1 standard deviation, okay? Now, like I said, we're going to use the normal distribution a lot this semester. There are 3 things. There's a special rule, and it's called the 68, 95, 99.7 rule. Isn't that a great name? Okay? The reason why we call it that is rule number 1 says 68% of your data are between -1 sigma and +1 sigma, okay? So what I've just drawn here, 68% of your data should be in between -1 sigma and +1 sigma, 1 standard deviation, okay? Rule number 2 says, 95% of your data are between, tell me your name again, it's Aaron.
Yeah.
Aaron, what do you think? What would you guess?
95 between -1 sigma.
2 sigma.
2
And?
sigma and -1 sigma.
+2 sigma.
Right.
Yeah. Can't be 1 sigma. I already got the first rule there. Okay? So what I'm saying here is between -2 sigma, +2 sigma, this area here in black works out to be 95%. And I'll bet that Braden can tell me what rule number 3 is.
99.7% between -3 sigma and +3 sigma.
Exactly right. He sees the pattern going on here. -3 sigma and +3 sigma. Okay? So -3 sigma, +3 sigma. This area here is 99.7% of your data. Okay? So this is a very important rule we're going to be using on the homework. Now, the last question that we have is, what if the data are not normal? Because not all data are normal. Okay? What if it's really crazy data? What if it looks like something like that? Okay? So we can't assume the 68, 95, 99 rule because that assumes your data are normal. If your data are not normal, okay, we have what's called Chebyshev's inequality. And Chebyshev's inequality says, let me make sure I get this right, for any distribution at least 1 minus 1 over k squared times 100% of your data will lie within k standard deviations. Okay? So, but the rule is k has to be greater than 1. Okay? So as we look at this, let's pretend that this is my mean here. Okay, if I go out 1 standard deviation, and if I go out 2 standard deviations, okay, the question is how much data are within 2 standard deviations here? Okay? So according to my formula, okay, let's go out 2 standard deviations. 1 minus 1 over 2 squared. 2 squared is 4. 1 minus 1/4 is 3/4, right? 3/4, which works out to 75%. Okay? So according to this, if the data are normal, we would expect 95% to be within 2 standard deviations. If the data are not normal, you would expect at least 75%. So greater than or equal to 75%. Okay? So that works with any distribution, but yeah, you're going to get a lot more if it's normal. But that works as well. Okay? Quiz tomorrow is on 3.2. See y'all tomorrow.